Hey students, in the previous videos we discussed the problems based on the reflexive, symmetric, transitive. So how to show the given relation as a equivalence relation, that all type of questions we discussed. In today's class also we are discussing some more important questions. So my dear students, already I discussed that a relation R on a set A is said to be reflexive if, here it is, if A comma A belongs to R for every A belongs to the set A. So if you are defining the relation R on a set A means every element of A should relate it to itself. If such a order pair will be there in the relation R means that relation R we can call it as reflexive. And next, second one, my dear students, symmetric. So a relation R on a set A is said to be symmetric if A comma B belongs to R. This must implies that the ulta of this, that is B comma A, must be in the relation R. Then such a relation R we can call it as symmetric. And third one, my dear students, that is transitive relation. A relation R is said to be transitive if A comma B belongs to R and B comma C belongs to R. Then we should check whether A comma C belongs to R relation or not, that we should check. If this condition satisfies, then we can call it as the transitive. A relation R is said to be equivalence relation if it is a reflexive, it is symmetric, and it is transitive. If all these three relations is satisfying means such a cases we can call it as the given relation as the equivalence relation. So my dear students, what is the given question here? It is show that the relation R in the set, this is the set given to you, on the set A you are defining the relation in such a way that here it is modulus of A minus B is a multiple of 4. So such a ordered pair we should take from this in the relation A. So is an equivalence relation. To show that, first what I will do, my dear students, I will write the given elements. Here it is, let A is equals to, so what is the set A given to you? The set given to you in the form of set builder form. Clear? So what are the elements here? What is the condition here? It is, so it is x belongs to z such that your x value must be greater than or equals to x, greater than or equals to 0 and less than or equals to 12, and it must be a integer. Such a numbers you should take in the set A. For that reason what I will do, my dear students, 0 less than x value must be at is greater than or equals to 0 sign. So 0 is included. After the 0, next number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So because x value is less than or equals to 12 and greater than or equals to 0. So these are the integers which contains in the given set A. Now my dear students, and here it is also, and R is equals to, what is the relation defining here? It is collection of all ordered pairs such that modulus of A minus B is multiple of 4. So this is the, here it is, relation, my dear students. So you should take the, in the relation R, how will be the ordered pairs? In this relation R, the ordered pairs satisfy this condition. What is the condition? If you take the difference of those ordered pairs inside the modulus, that is multiple of 4. Then what is multiple of 4? Multiple of 4 means you can take, here it is, if you multiplying 4 into 1 is equals to 4, 4 into 2 is equals to 8, 4 into 3 is equals to 12. So these are all we can call it as multiple of 4. So these you can call it as multiple of 4, and 4 into 0 is equals to 0. So these all numbers 0, 4, 8, whatever we have the numbers, my dear students, these all numbers we can call it as multiple of 4. It is nothing but table. Clear? Table means Maggi. So you can take, here it is, the condition R is. Now we should check. First one is reflexive. My dear students, we know that what is the condition for reflexive? Reflexive means ಎವ್ರಿ ಎಲಿಮೆಂಟ್ ಆಫ್ ಎ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ಅದೇ ಎಲಿಮೆಂಟ್ ಜೊತೆ ರಿಲೇಷನ್ ಹೊಂದ್ತಾ ಇರಬೇಕು. ಅಂಥ ರಿಲೇಷನ್ ಆರ್ಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ? ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂತ ಕರಿತೇವೆ. ಈ ಕಂಡೀಷನ್ನು ಬರೀ ಯಾವುದೇ ಒಂದು ಎಲಿಮೆಂಟಿಗಲ್ಲ, ಎವ್ರಿ ಫಾರ್ ಆಲ್ ಎ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ಅದೇ ಎಲಿಮೆಂಟ್ ಜೊತೆ ರಿಲೇಷನ್ ಇದ್ದರೆ ಅಂಥ ರಿಲೇಷನ್ಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ? ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂತ ಹೇಳಿ ಕರಿತೇನೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾ ಏನು ಮಾಡ್ತೇನೆ ಇಲ್ಲಿ ಫಸ್ಟ್ ಏನು ಮಾಡ್ತೇನೆ, ನಮಗೇನು ಗೊತ್ತೈತಿ? ಸೊ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಮೈನಸ್ ಎ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 0. ನಮಗೆ ಈ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಬೇಕು. ಸೊ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ಅದೇ ಎಲಿಮೆಂಟ್ ರಿಲೇಷನ್ ಇರಬೇಕು. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಏನು ಬರಿತಾ ಇದ್ದೇನೆ? ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಮೈನಸ್ ಎ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಮಾಡ್ಯುಲಸ್ ಆಫ್ 0. ಮಾಡ್ಯುಲಸ್ ಆಫ್ 0 ಈಸ್ ನಥಿಂಗ್ ಬಟ್ 0. ಕ್ಲಿಯರ್? ಸೊ ಹಿಯರ್ ಇಟ್ ಈಸ್ 0. 0 ಅನ್ನೋದು ಇಟ್ ಈಸ್ ಅ ಮಲ್ಟಿಪಲ್ ಆಫ್ 4. 0 ಈಸ್ ಅ ಮಲ್ಟಿಪಲ್ ಆಫ್ 4. Am I clear? Here it is 4 into 0 is equals to 0. So here it is 0. This number is, if you solve a minus a means you are getting 0. 0 is a multiple of 4. 0 is a multiple of 4 means this implies that a comma a, this ordered pair will be in the relation R, belongs to R. Here it is, how will be the, in this relation R, how will be the elements here it is, that is in this form, modulus of a minus b, if it is this number is a multiple of 4 means such a ordered pair will be there in the relation R. Here a minus a if I take means this is equals to 0 and this is a multiple of 4. If this a comma a is satisfying this condition means we can say that this a comma a is belongs to in the relation R. A comma is belongs to in the relation R. This is for every a belongs to a. So any integer you can take. So any element if you take means that is 1 minus 0 is 0. 1 minus 1 is 0. 2 minus 2 is 0. It means every element of a this condition will satisfy. So therefore we can say that the relation R is, here it is, this implies that R is reflexive. My dear students, please remember R is reflexive because every element is related to itself. That is all elements, this is for all elements of the set A. If this condition is satisfying means then we can say that R is reflexive. And next we will check for the second one is symmetric relation. ಇಲ್ಲಿ ನೋಡಿ, ನನಗೇನು ಬೇಕಾಗಿತ್ತು? ಫಸ್ಟ್ ಕಂಡೀಷನ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂತ ಹೇಳಿದ್ರೆ ಏನು ಹೇಳೀನಿ? ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂತ ಹೇಳಿದರೆ ಎವ್ರಿ ಎಲಿಮೆಂಟ್ ಆಫ್ ದ ಸೆಟ್ ಎ, ರಿಲೇಷನನ್ನು ಯಾವ ಸೆಟ್ಟಲ್ಲಿ ಡಿಫೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಆ ಸೆಟ್ಟಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ಅದೇ ಎಲಿಮೆಂಟ್ ಜೊತೆ ರಿಲೇಷನ್ ಇದ್ದರೆ ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೇವೆ? ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂತೇಳಿ ಕರಿತೇವೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಫಸ್ಟ್ ನಾನು ಏನು ಮಾಡಿದೆ, ಜನರಲಿ ನಂಗೆ ಏನು ಗೊತ್ತೈತಿ? ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಮೈನಸ್ ಎ, ಈ ಕಂಡೀಷನ್ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಅದೇ ಎಲಿಮೆಂಟ್ ಜೊತೆ ರಿಲೇಷನ್ ಇದೆಯಲ್ಲ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕಂದ್ರೆ ಈ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗ್ತಾ ಇದೆಯಲ್ಲ ಅಂತೇಳಿ ಚೆಕ್ ಮಾಡಬೇಕು. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಮೈನಸ್ ಎ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೆ. ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಮೈನಸ್ ಎ ವ್ಯಾಲ್ಯೂ ಏನು? 0 ಸಿಕ್ತು. ಸೊ 0 ಅನ್ನೋದು ಮಲ್ಟಿಪಲ್ ಆಫ್ 4 ಇದೆಯಾ? ಎಸ್, 0 is a multiple of 4. 0 is a multiple of 4. It means this ordered pair. ಸೊ ಎ ಮೈನಸ್ ಬಿ ಇಸ್ ಅ ಮಲ್ಟಿಪಲ್ ಆಫ್ 4 ಅಂತ ಹೇಳಿದರೆ ಎ ಕೊಮ ಬಿ ಈ ಆರ್ಡರ್ ಪೇರ್ ಈ ರಿಲೇಷನ್ ಇರ್ತದೆ. ಅದೇ ರೀತಿ ಎ ಮೈನಸ್ ಎನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ ಅದು ಮಲ್ಟಿಪಲ್ ಆಫ್ 4 ಅಂದರೆ ಈ ಕಂಡೀಷನ್ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡ್ತಾ ಇರ್ತದೆ. ಅದಕ್ಕೋಸ್ಕರ ಈ ಆರ್ಡರ್ ಪೇರ್ ಎ ಕೊಮ ಎ ಅನ್ನೋ ಎಲಿಮೆಂಟ್ ಎದ್ರೊಳಗೆ ಇರ್ತೈತಿ, ಆರ್ ಅನ್ನೋ ರಿಲೇಷನ್ ಇರ್ತೈತಿ. ಎ ಕೊಮ ಎ ಅನ್ನೋ ರಿಲೇಷನ್ ಆರ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ನಾನೇನು ಹೇಳ್ಬೋದು? ಆರ್ ಅನ್ನು ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂತ ಹೇಳಿ ಕರಿಬಹುದು. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್. ಸೊ ವಾಟ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್? ಹಿಯರ್ ಇಟ್ ಈಸ್, we should check that is symmetric. We should show that symmetric. To show symmetric, now let us consider, let a comma b belongs to R. One order pair I am taking from this relation R. ಸೊ ಎ ಕೊಮ ಬಿ ಅನ್ನೋದೊಂದು ಆರ್ಡರ್ ಪೇರ್, ಆರ್ ಅನ್ನೋ ರಿಲೇಷನಿಂದ ಒಂದು ಆರ್ಡರ್ ಪೇರನ್ನು ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾನೆ. ಸೊ ಒಂದು ಆರ್ಡರ್ಡ್ ಪೇರ್ ಆರ್ ಅನ್ನೋ ರಿಲೇಷನಿಂದ ತೊಗೊಂಡಿದ್ದಾನೆ ಅಂತ ಹೇಳಿದರೆ ಆಬ್ವಿಯಸ್ಲಿ ಅದು ಏನು ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡ್ತಾ ಇರ್ತೈತಿ? ಈ ಕಂಡೀಷನನ್ನು ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡ್ತಾ ಇರ್ತದೆ. ದಿಸ್ ಇಂಪ್ಲೈಸ್ ದ್ಯಾಟ್ modulus of a minus b is multiple of 4. So next this implies, my dear students, so modulus of a minus b is a multiple of 4 because ನಾನು ಆರ್ ಅನ್ನೋ ಒಂದು ರಿಲೇಷನಿಂದ ಒಂದು ಆರ್ಡರ್ ಪೇರನ್ನು ತೊಗೊಂಡೇನೆ. ಆರಲ್ಲಿ ಎಂಥ ಆರ್ಡರ್ ಪೇರ್ಸ್ ಇರ್ತವೆ, ಆರಲ್ಲಿ ಆರ್ ಅನ್ನೋ ರಿಲೇಷನಲ್ಲಿ ಎಂಥ ಆರ್ಡರ್ ಪೇರ್ ಇರ್ತವೆ ಅಂತ ಹೇಳಿದರೆ ಅದರ ಮಾಡ್ಯುಲಸ್ಸಲ್ಲಿ ಅದರ ಡಿಫ್ರೆನ್ಸ್ ತೊಗೊಂಡಾಗ ಅದು ಮಲ್ಟಿಪಲ್ ಆಫ್ 4 ಆಗಿರಬೇಕು. ಈ ಕಂಡೀಷನನ್ನು ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡುವಂತಹ ಎಲಿಮೆಂಟ್ಸು ಅಂದರೆ ಆರ್ಡರ್ಡ್ ಪೇರ್ಸ್ ಮಾತ್ರ ಈ ರಿಲೇಷನ್ ಆರಲ್ಲಿ ಇರ್ತಾವೆ ಅಂತ ಹೇಳಿ ನನಗೆ ಗೊತ್ತಿದೆ. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಏನು ಮಾಡಿದ್ದೇನೆ ಅಂತ ಹೇಳಿದರೆ ಈ ಆರಲ್ಲಿಂದ ಒಂದು ಆರ್ಡರ್ ಪೇರನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೇನೆ. ಸೊ ಈ ರಿಲೇಷನ್ ಆರ್ ಇಂದ ಒಂದು ಆರ್ಡರ್ ಪೇರ್ ತೊಗೊಂಡಿದ್ದೇನೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಈ ಕಂಡೀಷನನ್ನು ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡ್ತಾ ಇರ್ತೈತೆ. ಅದಕ್ಕೋಸ್ಕರ ಎ ಕಾಮ ಬಿ ಬಿಲಾಂಗ್ಸ್ ಟು ಆರ್ ಅಂತ ಹೇಳಿದ್ರೆ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಮೈನಸ್ ಬಿ ಈಸ್ ಅ ಮಲ್ಟಿಪಲ್ ಆಫ್ 4 ಅಂತ ಹೇಳಿ ಬರ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಮಾಡ್ಯುಲಸ್ ಇರೋದ್ರಿಂದ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಮೈನಸ್ ಆಫ್ ಎ ಮೈನಸ್ ಬಿ ಈಸ್ ಆಲ್ಸೋ ಈಸ್ ಮಲ್ಟಿಪಲ್ ಆಫ್ 4. Am I clear? So modulus of, here it is, ಈಗ ಯಾವುದೇ ಒಂದು 4 ಅನ್ನೋದು 4, here it is, modulus of 4 is equals to 4, modulus of minus 4 is also equals to 4. If 4 is a multiple of, here it is, if 4 is a multiple of 4 means the negative if you take means that is also multiple of 4 because inside the modulus you are taking. Am I clear? Or else leave this one, don't get confused. Simply ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇದೊಂದು ನಂಬರ್ ಇದೆ ಎ ಮೈನಸ್ ಬಿ ಅನ್ನೋದು ಒಂದು ನಂಬರ್. ಯಾಕಂದರೆ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಎಲಿಮೆಂಟ್ಸನ್ನು ತೊಗೊಂಡಾಗ ಅದೇನಾಗಿರಬೇಕು ಮಲ್ಟಿಪಲ್ಸ್ ಆಫ್ 4 ಆಗಿರಬೇಕು. ಸೊ ಯಾವುದೇ ಒಂದು ಎ ಮೈನಸ್ ಬಿ ಅನ್ನೋದು ಒಂದು ನಂಬರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇನೆ. ಸೊ ಒಂದು ನಂಬರು ಮಾಡ್ಯುಲಸಲ್ಲಿ ಇರೋದ್ರಿಂದ ಅದು ನೆಗೆಟಿವ್ ಇದ್ರೂ ಪಾಸಿಟಿವ್ ಅಂತ ತೊಗೊಳ್ಬೇಕು, ಪಾಸಿಟಿವ್ ಇದ್ರೂ ಪಾಸಿಟಿವ್ ಅಂತ ತೊಗೊಳ್ಬೇಕು. ಇನ್ಸೈಡ್ ದ ಮಾಡ್ಯುಲಸ್ 4 ವ್ಯಾಲ್ಯೂ is equals to 4 and modulus of minus 4 value is also 4 only. So therefore modulus of a minus b is a multiple of 4 means, my dear students, here it is, minus of this number is also multiple of 4. Here it is, minus of a minus b is also multiple of 4 and this implies that. So idan heng baribodu, minus anna take inside the bracket. Here it is minus plus b minus a. ಫಸ್ಟ್ ಬಿ ಬರಿತಾ ಇದ್ದಾನೆ, ಸೆಕೆಂಡ್ ಎ ಬರಿತಾನೆ, ದಟ್ ಈಸ್ ಅ ಡಿಫ್ರೆನ್ಸ್. ಆ್ಯಂಡ್ ಮೈನಸ್ ಸೈನ್ ಇನ್ಸೈಡ್ ತೊಗೊಂಡಿದೆ. ಸೊ ಮೈನಸ್ ಪ್ಲಸ್ ಬಿ ಮೈನಸ್ ಎ, ದ್ಯಾಟ್ ಐ ರೋಟ್. ಸೊ ಮೈನಸ್ ಆಫ್ ಬಿ ಮೈನಸ್ ಎ ಈಸ್ ಮಲ್ಟಿಪಲ್ ಆಫ್ 4 ಆಲ್ಸೋ ಐ ಕ್ಯಾನ್ ರೈಟ್. ಸೊ here it is, minus of b minus a is also multiple of 4. So ನನಗೇನು ಗೊತ್ತಿದೆ, ಮಾಡ್ಯುಲಸ್ ಆಫ್ a minus b is a multiple of 4 ಇದ್ರೆ a, b ಅನ್ನೋದು ಈ ರಿಲೇಷನ್ ಇರ್ತೈತೆ ಅಂತ ಹೇಳಿ ಗೊತ್ತೈತೆ. ಸೊ ಮಾಡ್ಯುಲಸ್ ಆಫ್ b minus a is a multiple of 4 ಅಂತ ಹೇಳಿದ್ರೆ ಇವಾಗ ಏನು ಬರೀಬೋದು, ದಿಸ್ ಇಂಪ್ಲೈಸ್ ದ್ಯಾಟ್ b, a is belongs to, it will be in the relation R. Am I clear, my dear students? So like this you should solve. So I'll erase this one and next here it is. What I considered, I assumed that one ordered pair is contained in the relation R. Then the ulta b, a is also in the relation R. So what it's, therefore what it implies, if a, b belongs to R, if it is implies ulta b, a is also R means then we can say that therefore R is symmetric. Therefore R is symmetric. And next the third condition is transitive. So what is transitive, my dear students? Transitive is, let us take, let a comma b belongs to R and b comma c belongs to R. What is the condition we have? If a comma b belongs to R and b comma c belongs to R, then we should check transitivity property. If a comma c is there or not, that we should check. So let us consider, my dear students, let a comma b belongs to R and b comma c belongs to R. So this implies a comma b is in the relation R means what I can write, my dear students? A comma b, it means modulus of a minus b is multiple of 4. And also b comma c is also in the relation R means modulus of b minus c is multiple of 4. This I can write, my dear students, because a comma b and b comma c are in the relation R. Am I clear? And this implies my modulus of a minus b is a multiple of 4 means here it is a minus b modulus of, if you remove the modulus means again the same number you are getting, modulus a minus b. I am removing the modulus. So a minus b is multiple of 4 and also, my dear students, b minus c is also a multiple of 4. And this implies if any number, here it is, a minus b is a one number, it is a one number you will get. Generally I am discussing If a minus b is a multiple of 4 and b minus c is a multiple of 4, means you can say that a minus b plus of b minus c is also multiple of 4. For example, you can consider here it is why it is so, means here if 4 is multiple, or else take it as 16 is, you can check my dear students, 16 is it a multiple of 4? 4 4 is 16, and another number take here it is 4 1 is 4, 4 is also multiple of 4. If you add these two, 16 plus 4 is equals to 20. So 20 is also multiple of 4. Therefore, my dear students, this number plus this number is also multiple of 4. If you add these two, what you are getting? A minus b plus b minus b plus b cancels, plus here it is. If you solve, means a minus b plus minus c. Plus b minus c got cancels, you will get a minus c. This is rough work I did, here it is. So a minus b, b plus c. If you solve this, means how much you are getting? A minus c. So a minus c is multiple of 4. So therefore this implies what I told my dear students. Any ordered pair inside the modulus, if you take any, here it is any two numbers, if you take inside the modulus, and if that number is a multiple of 4, means then those numbers a comma b, that order pair will be in the relation R. Here a minus c is a multiple of 4, so therefore I can write here it is this ordered pair a comma c is contained in the relation R. So what I considered, a comma b belongs to R, b comma c belongs to R, then a comma c is also in the relation R. So therefore I can say here it is, therefore R is here transitive relation. Therefore R is transitive. Therefore R, because of this result. And we show that, my dear students, we shown the R is reflexive, R is symmetric, R is transitive. Therefore R is an equivalence relation. Therefore R is an equivalence relation. So like this you should solve, my dear students. Very important such type of questions. And please see here this question was asked in March 2016 of Karnataka board second PC annual examinations. So this question was asked like this, you should solve. Very important and easy also. Please try to practice such type of questions. Am I clear? So still, if you have any doubts, you can comment me, my dear students. I'll reply for that, and we'll move to the next question. Please pause the video to note it down. The next question, my dear students, I wrote on the board, show that the relation R in the set R of real numbers. You are defining the relation R on the set of real numbers. And how will be the relation defined? The relation R is, my dear students, it is all ordered pairs a comma b such that a is less than or equals to b square. Your a value should be less than or equals to b square. To solve this, my dear students, first of all what I'll do, let us take relation R in the set R of real numbers. It means you are defining the, let us take a as, or else, my dear students, here you are defining the relation R on, here it is, set of real numbers. You can take this as a, or you can simply you can write it as set of real numbers. You can take this as, my dear students, a. Let a is equal to set of real numbers, and the relation R is given there, a comma b, such that a is less than or equals to b square. It is we should show that is neither reflexive nor symmetric nor transitive. For this, my dear students, first what I'll do, here consider the, here it is, you are defining the relation R on set of real numbers. So real numbers means it included all rational, irrational, integers, natural numbers. Every number will be there in the set of real numbers. Am I clear? So minus infinity to plus infinity on the real line, minus infinity to plus infinity, whatever number comes, those all numbers will be there in the real numbers. So my dear students, let us take one example, half. If I take half, a value as half and b value as, here it is. What is reflexive? Reflexive means here it is, every element a comma a must be in the relation R. So if I take half, my dear students, here half comma half if I take means, is half is less than or equals to half whole square? My question is whether half is less than or equals to half whole square. What is half, my dear students? This implies, here it is, half is like this, so less than or equals to 1 by 2 means 1 square divided by 2 square. So 1 square divided by 2 square means how much it is? 1 square is 1, 2 whole square is 4. So this implies 1 by 2 means 0.5 and 1 by 4 means, here it is, 2 point something it will come. It means, my dear students, here it is, 0.5 is not, here it is, 0.5 is not, yes, sorry, 1.5 means, here it is, it will comes, here it is, more than, here it is, the value whatever you will get 1 by 4, that value is not less, it is not greater than or equals to 0.5, my dear students. Am I clear? So therefore this is not, here you can write, here it is, 1 by 2 is not less than or equals to 1 by 4. Clear? And this value will be, here it is does not holds this 1 by 2. For that reason, since 1 by 2 is not less than or equals to 1 by 2 whole square, we can write, here it is, half 1 by 2 does not belongs to R. So if you take the number 1 by 2, so element 1 by 2 and 1 by 2 is does not belongs to R, therefore R is not reflexive, my dear students. If you want means you can use the calculator, further you can simplify, you can check, my dear students. Half is not less than or equals to, here it is, 1 by 4. This value is not less than or equals to, this condition does not holds, so therefore 1 by 2, every number 1 by 2 is not related to itself, so therefore this relation is not reflexive, this condition is not satisfying, so therefore R is not reflexive. And next, second condition, my dear students, if you take, let, here it is, 1 comma 2 is related to R. You can take, my dear students, 1 comma 2 is related to R because 1 is less than or equals to 2 whole square. It means 1 is less than or equals to 4. This condition 1 comma 2 is, here it is, 1 comma 2 is belongs to R, but 2 comma 1 does not belongs to R. Since you can write, my dear students, 2 comma 1 does not belong to R. Why? 2 comma 1 means what? This should satisfy this condition. 2 is not less than or equals to 1 whole square. Because 2 is less than 1 square is 1. So 2 is not less than or equals to 1. So therefore 1 comma, even though 1 comma 2 is belongs to R, but the reverse of this 2 comma 1 is does not belongs to R. Therefore R is not, here it is, symmetric. What is symmetric, my dear students? Symmetric means any ordered pair 1 comma 2 is belongs to R means the reverse of this 2 comma 1 must be in the relation R. But here it is 1 comma 2 is belongs to R, but 2 comma 1 is does not belongs to R. Therefore R is not a symmetric. And next, my dear students, third condition I can take. So what is the third condition? Third condition is transitive. We should show that even it is not a transitive also. To prove the transitive, my dear students, what I will take? Let us, here it is, if or else take 20 comma 5 belongs to R. 20 comma 5 belongs to R because 20 is, here it is, what is the condition? Here it is 20 less than or equals to 5 whole square. It means 20 is less than or equals to 25. So therefore 20 comma 5 will be there in the relation R. And next, my dear students, here it is 5 comma 3 I am taking, here it is, and 5 comma 3 is also in the relation R because 5 is less than or equals to 3 whole square. 5 is less than or equals to 3 whole square is 9. So therefore 5 is less than or equals to 9. It means 5 comma 3 is also in the relation R. A comma B is there, B comma C is there. Next we should check that A comma C. It means 20 comma 3 whether it is belongs to the relation R or not, that we should check. So what is this, my dear students? 20 comma 3 is, here it is, 20 is less, whether it is less than or equals to 3 whole square, please check. So 20 is less than 3 whole square is 9. 20 is not less than or equals to 9. 20 is not less than or equals to 9. So here it is 20 comma 5 belongs to R, 5 comma 3 belongs to R, but 20 comma 3 does not belongs to R. Therefore R is not transitive. So therefore R is not transitive. So my dear students, what they asked in the question, they asked you to show that the given relation R as a, here it is reflexive, symmetric, transitive. So here it is, since we proved, here it is R is not reflexive nor transitive nor symmetric. So therefore R is not reflexive nor symmetric nor transitive. Am I clear? So like this you can take any example, my dear students, which satisfy these conditions. Here I took 1 by 2 and here it is I took 20 comma 5 and 5 comma 3. Like this you should think and you should take the ordered pair. Am I clear? So like this you should solve. I hope you understood. Still if you have any doubts you can comment me, I'll reply for that. And next we move to the next question. So before that please pause the video to note it down. The next question, my dear students, I wrote on the board. What is that? Check whether the relation R defined in the set, here it is 1 2 3 4 5 6, as this is the relation they given to you. The relation should say, what is the condition, my dear students, in the relation R they given to you? B must be equals to A plus 1. Such a ordered pairs will be there in the relation R. We should check that whether it is reflexive or symmetric or transitive. That we should check. To check this, my dear students, here 1 2 3 4 5 6 only they given, here it is a finite definite numbers in the set they given to you. It means if they given like a set of integers or set of rational numbers or set of real numbers, means that case we'll discuss the general element we are taking a comma a, like that. But here it is in particular they given you definite numbers, my dear students. For that reason what I'll do, I'll first write the relation R. What are the elements will be there in the relation R, that I am going to check. So what is that? Let the set A, my dear students, let us take the set A as 1 2 3 4 5 6. These are the elements contained in the set A. And how will be the relation R defined? It is all order collection of all ordered pairs such that B must be equals to A plus 1. Such a ordered pair we should consider. So my dear students, we know that in the relation R, both A and B values in the ordered pair, every element must be in the relation in the set A. We should take every element in the relation R in the ordered pairs. Whatever elements we have, those elements must be from the set A itself always. So therefore what I will do, my dear students, R is equals to, here it is, let us take the A value. I am taking the A value from this set A. So if I take A value as 1, the first element is 1. If I take A is equals to 1, in this B is equals to A plus 1. So what happens, my dear students? B is equals to A value I am taking 1. 1 plus 1 is equals to, so B is equals to 2. So what is the ordered pair? If you take A value as 1, your B value is 2, 1 comma 2. So I'll write here it is 1 comma 2. And next, my dear students, next I'll take A value as 2. If you take A value as 2, so what is B value then? A plus 1 it is. So B is equals to 2 plus 1. So B is equals to 3. It means if you take A value 2, you are getting the B value as 3. And next, my students, similarly I'll take A value 3. So B is equals to A plus 1, B is equals to 3 plus 1, B is equals to 4. If you take A value as 3, you are getting B value as 4, like this. And if you take A is equals to 4 here, then B is equals to A plus 1, B is equals to 4 plus 1, so B is equals to 5. So therefore here it is 4 comma 5. And next, my dear students, A is equals to 5 I am taking. So B is equals to A plus 1, B is equals to 5 plus 1, B is equals to 6. If you take A value as 5, B value you will get it as 6. Am I clear? And next, my dear students, if you take A value as 6, B is equals to A plus 1, then b is equals to, here it is, yeah, what is a value? 6 plus 1, then you will get the b value as 7. But here it is a value, if you take 6, b value is 7. This is not possible because both your a and b must be values from the set A. 7 is not there, so therefore I can't take this ordered pair. So delete it, scratch it. So take only this much. So what are the order pairs? 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So my dear students, these are the only ordered pairs which satisfies this condition. So these are the ordered pairs will contain in the relation R. Now we should check that whether the given relation is reflexive, symmetric, transitive. My dear students, the given relation R is not reflexive. First condition I am going to write, R is not reflexive. R is not reflexive because here it is, R is not reflexive. You can write since, because what is reflexive? Reflexive in the relation set A means there must be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. But here it is no any elements contain, no any element is related to itself. So therefore R is not reflexive since 1, 1 is does not belongs to R. So this is therefore R is not reflexive. Next, my dear students, transitive. R is not transitive. Symmetric. R is not symmetric because 1, 2 is there. The ulta of this 2, 1 is not there. So therefore R is not symmetric. Clearly you can say R is not symmetric since 1, 2 belongs to R but 2, 1 does not belongs to R. And here it is, this order pair is there, but the reverse of this, ulta of this order pair is not there. So therefore R is not symmetric. And next, third one, my distance, 1, 2 is there, 2, 3 is there. It means here it is 1, 3 must be there. Whether 1, 3 is there in the given relation? No. So therefore R is not transitive. R is not transitive because we will write since here it is 1, 2 belongs to R and 2, 3 belongs to R, but here 1, 3 does not belongs to R. Therefore R is not transitive. Like this you should prove, my distance. So what they asked you to prove, or what they asked you to check whether the given relation is reflexive, symmetric or transitive. We should check. So I calculated, here it is. First I wrote the R, whatever elements order pairs will be there in the relation R, that I calculated. In examinations no need to calculate this all. If you know directly, you can write this also, my dear students, because easily you can, for your sake of understanding, I calculated all this. In mind only you can calculate. If you gave a value as 1, 1 plus 1 is 2, and next a value if you give 2 means 2 plus 1 is 3. If you give a value is 3 means 3 plus 1 is 4. If you give a value 4 means 4 plus 1 is 5. If you give a value 5 is 5 plus 1 is 6. Like this also you can write. But for the first time I am solving this question, so therefore I calculate all this. Am I clear? Still if you have any doubts, you can comment me. I'll reply for that, my dear students. So such type of questions will be asked in your annual examinations. Please try to calculate such type of questions. I hope you understood. Still if you have any doubts, you can comment me, my dear students. I will reply for that. So please solve such type of questions. Please pause the video to note it down. The next question, my dear students, again I wrote on the board, that is, show that the relation R in the set of real numbers is defined as R is equals to A comma B such that A is less than or equals to B, is reflexive and transitive but not symmetric. That we should show, my dear students. And this question was also asked in your Karnataka PU board examinations, annual second PUC annual examinations. This question was asked in March 2017. So such type of questions are very helpful, my dear students. You can easily get you can easily solve in your annual examinations. Clear? So sometimes they may ask for the 3 marks and sometimes they may ask for the 2 mark, but this question was asked in 3 marks. Whatever I am solving since from today's the 2 videos, whatever I am solving, those questions will be asked in your annual examinations for 3 marks, my dear students. Very, very important. So let us discuss this one. And next, my dear students, here it is. We should show that R is a reflexive. My dear students, here it is. Clearly you can say that clearly R, here it is, clearly A comma A belongs to R. We can say that, my dear students, any order pair, here it is, every element is, what is the condition? Every element is related to itself. That is the reflexive condition. If you take, my dear students, A, if you take the any number and that is always equals to itself, this means what is the condition given to you? A is less than or equals to B. If you take A is always less than or equals to A, here it is equals to sign. This means what, my dear students? This number is either it is less than or equals to this number or it is equals to this number. So we know that every number is equals to the same number. So therefore clearly A comma A is belongs to R. Here it is, since, if you want you can write since A is less than or equals to A. Therefore R is reflexive. Therefore R is reflexive. This is for all A belongs to capital R, that is real numbers. If you take any number, my dear students, 1 is less than or equals to 1, 2 is less than or equals to 2, 3 is less than or equals to 3. Am I clear? Every number is equals to itself. 2 is equals to 2, 3 is equals to 3. So therefore A comma A is belongs to R. Since A is less than or equals to A, so therefore R is reflexive. And next, my dear students, we should show that it is not symmetric. So to show the symmetric, first of all, this is your first condition, my dear students. And second one I am going to show, here it is, 1 comma 2 belongs to R. 1 comma 2 belongs to R. Why 1 comma 2 belongs to R? 1 is less than or equals to 2. Am I clear? I'll erase this one. Yes, 1 is less than or equals to 2, but 2 is not less than or equals to 1. Am I clear? It means 1 comma 2 belongs to R, but 2 comma 1 does not belongs to R. Therefore R is not symmetric. R is not symmetric. And next, my dear students, third one, this is for, here it is. And next, third condition I am going to discuss, that is transitive. We know that, my dear students, let A comma B belongs to R and B comma C belongs to R. So I am taking the 2 ordered pairs. So A comma B belongs to R means what it indicates? A must be less than or equals to B, and B comma C belongs to R means this element is B is less than or equals to C. This implies I am taking 2 ordered pairs from the relation R. If I am taking from this relation R means this obviously they satisfy this condition. A is less than or equals to B, B is less than or equals to C. And we know that this implies that, my dear students, if your A value is less than or equals to B and here B is less than or equals to C, it means A is less than or equals to C. If A is less than or equals to C means this implies that A comma C belongs to R. So A comma B belongs to R, B comma C belongs to R, even A comma C is also belongs to R. Therefore you can write R is, here it is, transitive. So therefore R is transitive, my dear students. So like this you should solve all the questions where here A, B, C, for all A, B, C belongs to the set of real numbers. Like this you should solve, my dear students. Still if you have any doubts, please comment me, I'll reply for that. We'll continue in the next video.